Okay, so here we are on 6.3, drawing similar polygons. Looks like the new skill they want you to work with is scale diagrams, and they're talking about artists and architects and planners using scale diagrams or models in their work. So they're using graph paper here to show that something's 1.5 times the original. Okay, so 1.5 would be a scale factor of 1.5. That's your scale factor. And then you would have to multiply the number by 1.5. You can take a look at, I'll show you one of these examples before we move on. So counting the grid sections 1, 2, 3, 4, 5, 6. So take that 6, that's the dimension that you're trying to scale. So times by 1.5, and that should be equal to 9. Now check this same dimension over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there you go. And you just do every dimension the same way, and you have similar results. The one at an angle is going to be challenging because it might not work out. Oh yeah, it does. It's right on the diagonal. So let's try the build your skills like always. And it says draw and label the lengths of the sides of a rectangle that has 8 centimeters and is similar to a rectangle that has a width 10 and length 20. So we'd match up this length 20 with this length 8. You go model, dividing original. Not sure why my pen is so blotchy. Okay, so model divided by original would be 20 divided by 8. So putting that in my calculator, I got 2.5. Okay, so this is my scale factor. Draw and label the lengths of the sides of a rectangle that has length 8 and is similar to a rectangle that has a width of 10 and a length of 20. So I'm not sure if they want us to use rulers here, but I'll just use a sketch. So I'm just going to sketch in the rectangle, and I will sketch in another rectangle. So here's 8, here's 20, and then 10 is on this one. So if I go 8 times 2.5 to get 20, then it's going to be some number times 2.5 to get 10. So all I have to do, basically 2.5 times some number, which we will call the width, is equal to 10. So divide that out. So 10 divided by 2.5 will be 4. So this width, this question mark here, is equal to 4. Alright, Maurice has drawn the plan for his backyard. However, he finds that the diagram is too small to fit in all the details. Redraw the diagram at 2.5 times the size of the original. Alright, so I'll just do a few of these and you get the idea. So I think they want us to use a ruler here. So let's just do a couple dimensions and then we'll move on. Alright, so that looks like it's roughly 2 centimeters. And I'll do the bottom one just for effect. You won't have questions like this on your test though, because we won't mandate that you need a ruler. So this is 3.5 centimeters. So I'll just do a couple of these dimensions. They want it at 2.5 times the size, so I just go 2 times 2.5, 3.5 times 2.5. Get those answers. This would be 5. This would be 8.75. So I would have to take out my ruler and draw. This would be 5 centimeters. This would be 8.75, and then I would just try to recreate this image using the scaled up numbers. Alright, take a look at number 3. Barney's house, 55 feet wide, 40 feet deep. Drawing of property shows that the house is 10 inch wide and 7.3 inch deep. What scale was used on the drawing? So with scale factor, you always use same units for the factor, because a scale factor is just a number and you need the units to go away, and in order for that to happen they have to cancel. So when you divide two things, the thing on top and the thing on the bottom ultimately have to cancel. So say you had a foot and a foot like this, they could cancel. But because you have feet and inch, that's not going to happen. So what we have to do is just convert some of these into, just convert the feet into inches, and then we'll be okay. So we know that 1 foot is worth 12 inches, so I need to multiply 55 and 40. Because if 1 foot is 12 inches, then 55 would be times 12 and 40 times 12. So let's get those. So it's 660 inch. And this is 480 inch. Scale factor is model divided by original. So 10 inches wide goes with 660 inches wide. So put the model on top. 10 inches divided by 660 inch. Inch cancels. 10 divided by 660 is 0.015. And the 1.5 repeats. So put a little repeater there. Now I sure hope that this next one is the same. So 7.3 inch divided by 480 inch. It better be. 7.3 divided by 480 is really close. There must have been some rounding happening. 0.15, and then the decimals after that are different. So what we'll do is we'll just say that the scale factor is 0.015. So here's the scale factor. Alright, number 4, some tables here. Second table, slightly larger version of the first. Give the dimensions below. Calculate what scale factor used to make the larger table. So this is superbly easy. You just take the model divided by the original. Make sure you're being consistent. Like if I chose this 37.5, I better go with 30. And if I chose 25, I better go with 20. Okay? And they should all be the same. 22.5 divided by 18. Got 1.25. I'll just check the other ones. 25 dividing 20, 37.5 dividing 30. Those should be similar. 25 dividing 20. Yep, that one's the same. 37.5 dividing 30. And yes, that one's also the same. Craft store uses gift boxes to wrap purchases. They have one box that is given. Another box is larger by scale factor 1.3. What are the dimensions of the new box? So each one of these dimensions needs to get multiplied by 1.3. That's how scale factor works. Each dimension is multiplied by the factor. So that's an easy question. 26 by 15.6 by 6.5. These are the dimensions of the new box. Here we have a kite. They want to make it bigger. The new kite has tail. Her new kite tail has length 49. What scale factor did she use? What are the kite's other dimensions? Okay, so with scale factor, it's always the model on top of the original. So the model is always the new thing. So it says the new kite tail has 49 centimeter. The original kite tail was 28 centimeter. Centimeters cancel because scale factor is just a number. 49 divided by 28 is 1.75. Okay, so to get the other dimensions, all you have to do is take the other dimensions and multiply by the scale factor. Then you will get the new dimensions. So again, pretty straightforward. And that's it for this section. So I would make sure that you do these three for sure. Yeah, and these ones look good too. And we are not going to be you're not going to be doing 6.4. So there won't be a video for 6.4. Finish the 6.3 homework and then go to the chapter test. And in the chapter test, just omit number 7 in the chapter test. Yeah, and that's it for the unit. So skip the 4th section, don't do 6.4, and then work on the chapter test.